Okay, hello. Welcome to practice quiz 11.2, 11.3 on circles and parabolas. So this practice quiz is pretty much one-to-one with what you can expect on the actual quiz, kind of as usual. And I'm just going to go through it. And this one should be easier than the ellipses and hyperbolas one. So here we go. So it said, given the equation 3 times, blah, 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 you can read all that. Find the center point and find the radius. Well, that's pretty easy, right? Because we know that x minus h squared plus y minus k squared equals r squared is the standard form equation of a circle. Notice that these 3's here, they're both coefficients on there, right? I don't have coefficients in standard form, so I need to get rid of those 3's, meaning I need to divide. So I'm going to divide by 3 on both sides. Then I will get x plus 10 squared plus y plus 6 squared equals, what's 108 divided by 3? It should be like 36, I think. Yeah, okay. So now it's in standard form, right? So the center is at negative 10 comma negative 6 because you just kind of flip the signs for h and k, right? And then the radius, that's r, equals, well, r squared equals 36. So r equals 6. So that's my radius. And that's it. Wow. Okay, let's move on. Let's write the equation of a circle with 2 endpoints on the diameter. Okay, so I got some circles. So this would help to sketch a quick Cartesian plane, like so. And it doesn't have to be to scale. It just needs to be, really just think about what quadrants these are in, right? So 2 comma negative 7, that's right 2, and then down 1, 2, 3, 4, 5, 6, 7. So that's about right here. And then 8 comma 1, that's 1, 2, 3, 4, 5, 6, 7, 8, comma 1 is right here. Okay, and so that's my diameter connecting those 2 points. Nice, right? Nice. So that's 8 comma 1, and that is 2 comma negative 7. Like so. All right. I'm gonna, I know that this makes a circle, but do I really need to draw the circle? I suppose I can, right? If you want me to, probably look something like this. Something like that, right? I wonder, you know what? Hold on. I wonder if I can get this thing to do a perfect circle. That would be awesome. Let's see what the iPad does. Whoa. Okay. You know what? I love it. I'm just gonna, here's what I'm gonna do. I'm gonna make that 8 comma 1. I'm just gonna edit it a little bit. Look at that perfect circle. Nice. So those are my 2 endpoints on the circle. Okay? All right. Nice, perfect circle. Okay, so what am I doing, right? Well, you need 2 things for the circle, right? You need to find the center, and you need to find the radius. Now, in order to really find that radius, we probably should find the center first. But let's just, you could do it in any order, right? So I know that because this is diameter, right? The radius is half of this. So somewhere halfway, right, that's where the center is going to be. So I could make a right triangle out of this if I like. So I could make it go here and then drop this down here, right? And then I'll say, okay, well, this distance from here to here, that's from 2 to 8, that distance is 6. And this distance from here to here, that is from negative 7 up to 1, so that is 8. So I can make a similar triangle going halfway in each direction, right? So half of 6 would be about 3. So this would be here. And half of 8 would be 4. Oh, sorry. From here to here. That'd be 4. So this length is 3 and this length is 4. So you can either think 3 to the right or 3 to the left, depending on the point you're talking about. So if let's say I have the point 2, -7, the center, right? The center is 3 to the right and 4 up. So it is, instead of brain fart there, 5, -3. Is that right? And to be honest, depending on how I'm drawing, let's see here. 1, 2, 3, 4, 5. Okay, I'm a little off because it looks like 6. But then 1, 2, 3. It's not so bad, right? It's pretty good, I think, at least. So there's my center. And then what's my radius, right? Well, if I zoom in on this triangle, right? So this triangle here. Oh, sorry. Let's make this point, and then I'll make a straight line here. This point, and then down, and then here. Okay? That's not a right triangle, and I am bothered. Oh my gosh. Let's make a right angle like this. There we go. Look at that. Thanks, iPad. Ooh, look at that triangle. Okay, so anyway, that point right there is 5, -3. And this point up here is 8, 1. And you can see the side length 3, 4. And if you know your Pythagorean triples, you know that this hypotenuse is 5. And if you didn't know that, c squared equals a squared plus b squared. So a squared is 3 squared, then 4 squared. That's 9 plus 16, which is 25. Therefore, c equals 5, if you didn't know. Okay? So the radius is 5. So radius is r equals 5. Center at 5, -3. Therefore, I can write the equation now, right? Because it's x minus h squared plus y minus k squared equals r squared. Whoop. So it is x minus 5 squared plus y plus 3 squared equals 5 squared is 25. Alrighty. There it is. So yeah, you want to use Pythagorean theorem here. That's helpful. I'm not sure how else you could do it. I mean, I'm sure maybe there's another way. It's always more than one way to do things in math, but yeah. Okay, number 3. Let's write the equation of a parabola with a directrix at x equals 5 and a focus -3, 7. I say this is probably going to be the most challenging question on your quiz, just because, like, what the heck does this look like, right? So you have to remember, is it vertical or is it horizontal? Is it facing left or is it facing right? So we need to work kind of abstractly here, right? Sketching a picture is going to help. So directrix at x equals 5. So that's 1, 2, 3, 4, 5. So this line is going to be my directrix. All right, that's my directrix at x equals 5. And then the focus is at -3, 7. So that's going to be 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. So it's about there, and that's going to be my focus, right? So because I've got it this way, right, I should see, like, okay, the vertex needs to be in between those, and it opens it opens away from the directrix. So if the directrix is here, then it's going to open this way with the focus like that, yeah? So that's where my parabola is going to be. So I need to figure out where the vertex is So I'm basically just going to look at this distance here, right? From here to here. Okay, I don't like what I drew. From here to here, right? And I want to be halfway in between that. So the focus is at -3. The direction is at 5. So what's halfway between 3 and 5, right? Well, that distance is 8, so it should be 4. So 4 less than 5 and 4 more than -3 is at 1. So that's going to be my vertex. And that vertex is going to be at 1, 7. Okay? So my vertex is at 1, 7. Because it's halfway, right? It has every point on the parabola is just as far away from the focus as it is the directrix. And so what is the value P, right? Well, this distance, which we just found, right? That's P. And you could say that this is also P, right? So 2P equals 8. So divide both sides by 2, P equals 4. And that's the focal length, right? So, okay, which way is it opening again, right? Well, it's opening, oh sheesh, I need to draw this. It's opening like this. Sorry, I kind of want to make a nice parabola. Okay. It's just a sketch, right? I don't need to find, 3 points, blah, blah, blah. I'm just sketching it here. So it opens left. So P is negative, right? And we use, what is the standard form, right? Well, if it's opening horizontally, then it's going to be y minus k squared equals 4p times x minus h. So, h comma k, that's 1, 7. So I should have y minus 7 squared, because that's the k value, equals 4 times p is -4, right? So, say p equals -4, not 4, right? And then it's x minus 1. So 4 times -4 is -16, so I'm pretty much there, right? Y minus 7 squared equals -16 times x minus 1. Beautiful. Beautiful. And we've done it. Hooray. Okay. This is going along nicely. Okay, let's do the last one here. Now let's graph the conic section. And now look, if you could do that one, you absolutely can graph the conic section. This one should be a gimme, yeah. Because I think the other one's much harder to do. So, okay, let's see. The vertex is h comma k. So x, right, it's x minus h squared equals 4p times y minus k. So x is 5 and h is be -2. So 5 comma -2 is down here. That's my vertex. Now see 4p equals 12. Therefore p equals 3 because it's just 5 both sides by 4. So p equals 3. Which direction is it opening? Opens up. Why? Because it's x squared and p is positive. Okay, if p were negative, then it would open down. But then, and I know it's vertically because x is squared. So p is going to be a distance 3 up. So it's going to be, if that's the vertex v, it's up 1, 2, 3 here. That's at 5, 1. And then the directrix, that's my focus, directrix would be back 3. So 1, 2, 3 down here. So this line is the directrix. I'll call that D. Yeah? And that's at y equals -5, keep it, please, please, please keep in mind. If you say -5, I don't even know if I'm going to give a point. You need to, some of you are not in the habit of writing this as a line yet. You need to. All right, I'm sorry to be all picky and blah, blah, blah. Oh, Mr. Spake is really better. Yeah, it does. It absolutely does. Because if you write x equals -5, then that's this line, and that's not correct, right? If you just write -5, well, what the heck does that mean? Yeah? I know it's picky. I know. I'm just being a teacher, okay? Being a teacher here. You got to have that equation, okay? And so the axis of symmetry, right, that's going to just be kind of down this way because it's going to be perpendicular to the directrix through the vertex and focus. So that's my axis of symmetry, which is going through 5. So there we go, x equals 5. Oh, see, there's the difference, right? I got to have those equations. And we're almost done, but we do need a graph. And to graph this, we need at least 2 more points because we have the vertex, but I kind of need to know how wide it is, right? So you might say that the focal width, which we're not being assessed here, right? But the focal width is 4p. So that's 4 times 3 is 12. Oh, wow. That's the coefficient here. Did you know that? Did you know that it's the focal width? Whoa, times that. Oh my gosh, that's crazy. Okay, anyway. So 4p is 12. So 2p equals 6. And I'm going to go 6 to the right and left of the vertex. So 6 to the right is not to the right of the vertex, the focus. So 1, 2, 4, 5, 6. Right? And then 1, 2, 3, 4, 5, 6. Those are going to be the 2 points here. And then I'm just going to try and draw a parabola as best I can. Now, look, the more points you find, the more accurate the parabola is going to be. But remember, our graphing expectations are, if you can find 3 points, tells me kind of how wide, how open this parabola is, roughly. And that's good enough. Sick. Look at that. Ooh, that is a beautiful parabola. I mean, it's not perfect, but it's a darn good sketch, I'd say. That's what I think. So, awesome. We did it. Hooray. Okay, well, thanks for sticking around. Hope this video was helpful. Be careful with P being positive and negative. Just be really careful about the direction this thing opens. Circles should be pretty straightforward. Don't forget your Pythagorean theorem, and I think you'll be fine. I think you'll be good. Okay? Good luck, and I'll see you later.